there was a problem where you had all of these rules and these hard-coded predicates and things, and it was just difficult to interpret it correctly. This way, you can. This is the failure of the Lisp machines and so forth. This way, you can actually start to learn things that experts are not able to articulate to you. And so, one concrete example of that is this following experiment, and I put it as a joke. So, a physicist, an engineer, and a machine learner drive to the bar. Who's the designated driver? Well, this is what happens when you get a physicist to drive. I know a physicist that drives like that. And they're trying to park the car between these two cones. And technically what they did here was they used an open loop control theory technique, which means there was no feedback. It was just did the equations according to physics, it had a desired trajectory, and it missed twice. Kind of went right up on the cones there. What about the engineer? So in this case, they used a feedback system, so they had this linear quadratic regulator controller, which meant it looked at the error and tried to stay on the trajectory, but it wasn't thinking far ahead. And it didn't even make it into the cones. You know, like, are we there yet? You look at the curve, you're not even. This is what happens when you get a machine learner to do it. And not do it themselves, but combine the physicist with the engineer. This is parallel parking at 40 kilometers an hour. So what's happening there is they had both of these techniques, and they trained a system to learn when to use one or when to use the other. And so it statistically learned, okay, it feels like I should use the physics right now. Oh no, the physics isn't working. Let me switch to the closed loop. So this is neat, because we're using machine learning to combine existing techniques. And this is the inspiration that went into Watson. Okay, so I told you about that big meeting at Dartmouth where they talked about artificial intelligence. We had one of those too, and these are some of the important people that held that. And there's a document produced. I don't think a lot of people have read it, but there was a document produced. And the document reads like scientists. First of all, they start complaining about what's wrong with doing science in the field. And they say it's difficult to discover what algorithms are important to QA. So the way question answering typically works is some university will build a system, and only they know how it works. So it's difficult for anyone else to replicate that or reproduce it. It's difficult to identify exactly what it is in their system that's giving them good performance or bad performance. And ultimately, in this document, they advocate for a open effort in question answering. So open source, open project where people can contribute things, where they can have shared data sets and work together. They also produce these graphs.